Welcome. Our team is here to discuss the challenges and opportunities presented by the emerging UAS or drone market. Um, so the four of us will walk through our analysis of this market as a whole and discuss the opportunities that your firm could potentially benefit from um, by pursuing opportunities in this market.
The FAA defines unmanned aerial systems as the unmanned aircraft plus all of its associated support equipment, including the control station, data links, telemetry, communication, navigation equipment, etc., that is necessary to operate the unmanned aircraft. The unmanned aircraft is the flying portion of the system. It can be flown via a pilot on the ground or autonomously through the use of an onboard computer with communication links and any additional equipment that's necessary for the aircraft to operate safely. This diagram demonstrates how these parts interact. Typically, the unmanned aircraft has some sensor load attached and is launched by various means depending on what type of aircraft it is. It can be controlled by a ground operator or flying autonomously. Either way, it communicates with the ground station via some wireless control when data links. The data collected by the sensor can be used real time or stored for analysis. The forms of the unmanned aircraft is as varied as its potential applications. Some unmanned aircraft control their own flights, flying autonomously using a pre-programmed flight plan or following a set of instructions, while others are controlled by humans on the ground. Fixed-wing unmanned aircraft, which can often fly longer and more efficiently than rotary blade vehicles, which can take off and land and maneuver in more crowded environments. Most unmanned aircraft are in the model aircraft size and price, which they range up until much larger vehicles that have space-age components and higher payloads. And the prices generally scale with this as well, ranging from in the low hundreds to tens of thousands of dollars for the largest and most advanced style drones, including the sensor package and all the other. According to a study by the Association for Unmanned Air Vehicle Systems International, the economic impact of integration of unmanned air systems into the airspace will total more than $13 billion in the first 3 years and will grow substantially into the foreseeable future, culminating to more than $82 billion between 2015 and 2025. Integration into the airspace will create more than 34,000 manufacturing jobs and more than 70,000 total new jobs in the first 3 years, with over 175,000 unmanned aircraft expected in the air by the year 2035. With all these aircraft, there will be a wide range of applications spanning all kinds of industries, as this chart indicates. Some other uses that are also being explored include wildfire mapping, other disaster management, thermal infrared surveys, weather monitoring, freight transportation, all kinds of exploration, and many, many more. The reason that unmanned air systems are useful in so many fields is the multitude of capabilities. Miniaturization of technology allows increasingly sophisticated sensors to be placed even on small aircraft. These sensors include electro-optical, i.e. cameras, video recorders, infrared, and radar. Advances in material also allows the UASs to carry communication equipment to increase wireless range or to add temporary coverage to remote areas. Major companies such as Amazon and Google have announced that they are trying to develop air systems for super quick delivery, and other groups are working on making deliveries to hard to reach areas, such as delivering supplies to people trapped on mountaintops. With these advances in sensors and the ability to fly inexpensively, unmanned aerial systems are good for large-scale mapping programs, including 3D ground mapping. The ever-expanding capabilities of these systems help provide increasing value for users. The flexibility of the platforms can be used monitoring crops or fencing. Being smaller and cheaper than manned aircraft Collecting data is more affordable, so it is possible to collect more of it than ever before, and to collect data from places that it was not possible to collect data from before. Also, these smaller sizes, they can be used in locations that are currently too risky or too expensive to use manned airframes for. All of these traits add both capabilities and reduce costs. There was a recent Wall Street Journal article that featured a Greek land surveyor who's been able to reduce his workforce from 12 to 2, instead using drones to cover massive amounts of land. The cost of the unmanned aerial system is significantly less than using manned aircraft or other means for these applications.
To determine where UAVs fit in the Abernathy and Utterback life cycle model, we need to define all three phases. The initial phase, which is labeled the fluid stage, is defined by the lack of dominant design, lots of innovation, and the identification of competitors being unknown at this point. The second phase is the transitional phase. The transitional phase is a process innovation dominates versus the product innovation dominating like in the previous phase. The last phase is the specific phase, which is defined by having well-established competitors and tools of competition become based on differentiating costs and product features. UAVs clearly fall into the fluid stage. There are numerous indicators that point to UAVs being in the fluid stage. The overall market is new, emerging market. It is only recently that UAVs for commercial use have come about. Due to it being so new, on the most efficient design is the main focus. Once this has been mastered, we see the process of producing UAVs being improved. But as of yet, this is not the primary focus. Since there is not mass-produced UAVs currently, identifying who the competitors are going to be is still very difficult, which also makes protecting against imitators that much harder. It is evident that there is growing concern for those pioneers in this industry as the application for patents on the components of UAVs in the last decade have increased dramatically. As evidenced by this chart, through most of the dimensions of UAVs are still in the fluid stage, some of the elements such as R&D and the equipment used are already progressing to the transitional stage. In the future, we will see UAS move out of the fluid stage into the transitional phase, which will allow for new innovation to make the production of these devices more affordable. One process that has already made this evident is 3D printing on UAS prototypes. According to an article in the Aerospace Conference written by Glinowski, students at the University of Virginia use this method to make UAS that would normally take months to make and cost nearly $25,000. Theirs cost only $2,000. In addition to make this more time efficient and affordable methods of production, the FAA is already being led to address and start regulating the commercial use of UAVs in the future. This is only going to lower the entry barrier for competitors. The natural leaders are clearly going to be those that have already been in the industry when it came to its military applications, but due to UAS appropriability, there is still going to be room for new entrants in the industry. The commercialization of UAS is also going to open a market for those in the sensory industry, as this is a necessary component of most of these devices.
As an investor in UAS technology, it is important to know when the market will be successful in employing drones to enhance its products and services. For a company to fully employ the technology, it first must determine whether it will be more beneficial than current methods, taking into consideration both quantitative and qualitative factors. This sounds pretty simple, but let's examine a potential example. A hiker is lost in a canyon. Two teams are available for deployment to search and rescue. A traditional team with helicopters and vehicles on the ground, and a team of drones with a ground station. Which team will be more cost-effective, cover more ground, arrive fast enough to save the hiker, over the long run be more effective at finding the hiker? Unlike manpower, drones can perform surveillance on an area much quicker, and unlike helicopters, they can go into some areas that the helicopters can't, like ravines and thick woods. But there are some shortcomings to using UAVs for surveillance. Some UAVs have a time constraint, as they are electrically powered and can't always stay in the air as long as manned helicopters. Also, the quality of the image obtained by the UAV versus that obtained by the helicopter needs to be taken into consideration. UAS technology is fairly new, so employing the technology at a point where time and innovation have progressed enough to allow for a cost-beneficial transition is key. Law enforcement and search and rescue teams, however, might have arguments that cost benefits are to be ignored to some degree as long as the technology is more effective in the other three areas, as it could save more human lives. Another factor affecting strategy with the technology's development is the concept of appropriability. Technology has loose appropriability and is thus available to most anyone, and thus this affects several other strategic concepts as well. Any first-mover advantages may be limited and subject to a learning curve, primarily due to educating the public as to the benefits and functionality, addressing safety concerns, and also privacy concerns, and most UAVs are equipped with cameras. The optimal time to engage in this technology is once the learning curve has steepened and the public's concerns are substantially being addressed. This is soon approaching as the FAA begins to regulate UAV flight. Because the loose appropriability would foster competition among companies in similar industries, this would likely place emphasis on a company's ability to master the use of the technology through component technology, such as those identified here, that would enhance the UAS's features and functionality. Thus, the hiring of key personnel to oversee the implementation would be crucial to the program's success. Defender types would be enabled as their ability to provide products and services effectively and efficiently would be increased. Because the technology is still not widely implemented by the market, features are not fully developed for the wide variety of drone uses. A patent race could likely ensue as manufacturers and developers seek to capitalize on this emerging technology.
Regulatory hurdles, primarily in the United States and Western Europe, that are creating high barriers for entries to new firms in these countries. These challenges would disadvantage US-based firms and could potentially give firms in other nations a head start in developing a technological lead in the drone market. Despite the launch of additional drone test sites, the FAA has not provided clarity around the regulatory environment impacting many commercial drone applications. The limited number of commercial drone testing sites will correspondingly limit research and development for potential firms who do not have access to these 6 sites. The market challenge outlook is improving given the recent breakthrough approvals which the FAA has provided to 4 US firms to operate drones commercially. The major implications are that this bodes well for the future of the industry, as leading experts and investors expect that the FAA will relax restrictions on other commercial drone applications in the near future. This means that any investors considering entering this market on the ground level should quickly ramp up its capabilities in the very near term. In addition to the wider regulatory environment, firms considering entering this market should be sensitive to the public's concerns regarding privacy infringement which may be caused by UAV and drone technology. Regulators could respond to the concerns of the public by imposing altitude restrictions in urban areas, which could rule out some retail and delivery applications of drones altogether. The FAA could thus be more likely to accept automated drones versus those at the mercy of human intervention. These with pre-approved flight plans could decrease concerns for the loss of privacy, as the FAA could get comfortable with the fact that the drone would only be surveilling a certain piece of real estate, or it won't go above a certain altitude as to infringe on others' privacy. This method could also reduce the risk of interference with larger manned aircraft. In addition, the GPS coordinates of drones' target location could be transmitted to and cleared, as well as tracked by the FAA on a continual basis. Finally, safety is, of course, a risk to any commercial drone implementation. Commercial drones create risks of property damage, injury, and death, which are possible when operating in large populated areas. Firms entering this market need to be prepared to bear any costs of litigation should their UAVs crash due to mechanical or operator failure. Mitigation of these safety concerns through equipment maintenance and high standards for drone operator training are possible and should be a focus for any firm entering this space. However, U.S. military operators are highly trained and have still caused accidents resulting in millions of dollars of damage. The least risky approach is to invest in automation, which can reduce the risk of operator error. However, this will still require more sophisticated technology and higher initial investments in research and development. Based on the findings of our analysis and research, our recommendation is for your firm to invest in commercial drone products. Despite all the risks outlined, this market is on course to quickly grow once the FAA clears any regulatory barriers. And based on the huge potential market size and growth potential over the next 10 years, firms who enter on the ground level should expect large returns and the ability to quickly capitalize on their initial investment. In summary, firms that make the investment early in order to enter this market and help develop this market should benefit from future potential of the drone as a platform technology, which will enable new products and services, which could cause existing firms that decide to go and take this course of action to quickly grow and increase their market share.